Alright, we're going to be going over the 3D dynamic programming for the Floyd Warshall algorithm on this graph right here. Alright, so below this graph is just the adjacency matrix. You read it by just the connection between 0 and 1 is -2. And then the connection between 1 and 2 is 1 and 2 is 2. So it just goes off weight. Okay, so we're given this recurrence here, and I'll explain what each part means. Okay, so K is how many times you've edited the graph, or like the iteration on which graph you're on currently. Ij is the index at which the value's at. So to start with this recurrence, you create a graph and you label it d to the -1, and this is going to be our very first iteration, so this acts as our base. Okay, so this part of our recurrence, we're only going to do once. Okay, so these two parts will only be done just once on this first initial graph. All right, so this first part, what does this mean? Okay, so in this case, K is -1. So we satisfy the first condition, and then I equals J. Okay, so what does that mean? So notice here, I equals J on the diagonals, because 0, 0 is here, 1 and 1 is here, 2 and 2 is here, and 3 and 3 is here. Okay, so what does it say if we meet these conditions? What does it say to do? We fill those with zeros. Okay, so let's fill these with zeros. And then the next condition, it says the weight at Ij, if K equals -1, which it does, which this is our initial graph, so K equals -1, we just place the weight at Ij from the adjacency matrix. So we're just going to take the weights from here and just transfer it over here. So -2, 2, -1, 4, and 3. Okay, and that's basically what the first two operations are. This is basically just creating your initial matrix, which in other words just means taking your adjacency matrix and filling the diagonals with zeros. That's what that means. Okay, and now once that's done, we're going to lock this in place, so d -1 won't change anymore, and we're going to define a new graph, which is labeled d0. So we just increment 1 from -1, and this acts as our next iteration on our graph. So this is what we're going to be working on now. Okay, and now we just focus on this last operation here. The recurrence is split up into 3 parts. So this is the first part, second part, and this is the third part. Okay, so what this does is it compares this value with the sum of these two values, and it takes the minimum of that, and whichever is the minimum of that, we just place it in this graph here. Okay, so we can start with the first case, which is here. Let's compute this real quick. So d, what is K in this case? K is 0. So 0 minus 1 is -1. And what this d -1 means, basically means to refer to this graph and grab some value from it. Okay, so we have d -1, and then I and J are both 0, since we're just starting from the first box here. Okay, now let's come here, let's do the same thing. So K minus 1, 0 minus 1 is -1. Okay, I in this case is 0 again, and K is 0. Okay, same thing here, d -1 and K is 0 again, and J is 0. Okay, now we just have to grab the values from these. So how to read this is just go to d negative 1, which is here, and grab the value at 0, 0. So it's right here, okay? This equals 0. All right, let's do the same thing for here. So go to d negative 1 and grab 0, 0. It's 0 again, and it's gonna be the same thing down here, okay? And now what the recurrence is saying is combine these two and then compare it with this. So what's the minimum of 0 and 0? In this case, it's 0. So we're gonna fill this out. All right, and now once we fill that out, we can move on to j plus 1. So we just move 1 to the right. All right, now we just replace wherever j is, we increment it by 1. So we can just erase these previous values and just put 1 instead. All right, and now we just repeat the process. So at d negative 1, what's the value at 0, 1? It's negative 2, okay? What's the value at 0, 0? It's 0. And what's the value at 0, 1? It's negative 2, okay? Again, we're going to combine these and then compare it with this. The minimum of negative 2 and negative 2 is negative 2, so we're just going to keep it like that. Also, the blank spaces here, and all the blank spaces like here, 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 that represents infinity, okay? So just keep that in mind. All right, now we can increment j again. So now we're at j equals 2. All right, and then here, okay, we can change this to 2 and change this to 2. All right, so now the value at 0, 2 is infinity. The value at 0, 0 is 0. And the value at 0, 2 is infinity. Combine these, then compare. So the minimum is just infinity. So we can leave that blank. And if we do j equals 3 now, it's going to be the same thing. So I'll show you guys real quick. So 0, 3, 0, 0, 0, 3. It's just going to be infinity again. Okay. Now that we process the first row, I'm going to leave it like this because this is the output. We're going to move down I. So we're just going to go to I equals 1 and restart on 0, on j equals 0. Okay, so let's rewrite these real quick. Okay, so I in this case is now 1, j is 0. I is 1, k is still 0, so we can just keep that there. K is 0 still, and j is 0. Okay. So now this is saying come to this d negative 1 graph and take the 1, 0 value, which in this case is infinity. All right, we fill that out. Now here it's the same thing. We grab the exact same value, so we do that. All right, d1 of 0, 0 is 0. We're going to take the minimum. Okay, in this case it's just infinity, so we're just going to leave that blank. All right, now again we're just going to edit j. So here and then here. J is now 1. We can grab the new values. We can do at 1, 1 is 0. At 1, 0 is infinity. And at 0, 1 is negative 2. We're going to take the minimum here. So infinity plus negative 2 is just that. And we compare it with 0. And the minimum is obviously 0, right? So we're going to fill that in right here. All right. Now we move on to j equals 2. So we come here. And we can replace j with the new value. So j is now 2. And notice that this value only changes when the row changes. So for this entire row, this middle value will stay the same always. And then it will only change once we move down a row, or once we change rows. Okay, so let's just grab these new values. So d of negative 1 at 1 and 2 is 2. D of negative 1 at 1 and 0 is 0. And then at 0, 2 we have infinity. All right, the minimum is going to be 2, so put that there. Okay, and for time's sake, we can just skip to the very last iteration. So 0, negative 1 here, and then let's process the next row, okay? So now let's say we're on I, so we processed all these rows, and now we're on I equals 3, which is the last row, all right? And then we're on j equals 0. So I is now 3, j is 0, I is 3, k is 0, okay, k is 0, and j is 0. Okay, so at d negative 1, what's the value at 3, 0? So it is 4. Okay. Now what's the value at 3, negative 0? Or 3, 0? It's 4 again. Okay. And then at 0, 0, it's just 0. So we take the minimum, then compare, or we add these two, then we compare which one's the minimum, which is 4 in this case. So we fill out 4 here. Okay. Now we move on to j equals 1. Let's replace these values with the new j, which is 1. Okay, what's the value at 3, 1 from d negative 1? It is 3. Okay, what's the value at 3, 0? It is 4. What's the value at 0, 1? Negative 2. Okay, we're going to combine these, which becomes 2. Then we're going to take the minimum. What's the minimum between 3 and 2? It's 2. So we fill in the new value here. Okay, and for time's sake, this just remains as 0. Okay, now once all that processing is done, we're going to define a new graph called, so D0 turns into D1. Okay, I have that defined right down here. Okay. All right. So D0 is finished. Now we create a new graph called D1, and we repeat the process. Okay. So in this case, k is now 1. So 1 minus 1 is 0. And what this is doing, we're going to refer to D0 now instead of D negative 1. So basically, you're just referring to the previous graph to compute new values. And this will find the shortest distance from node I to j using only intermediate nodes. Okay, so we can run through the first couple values. So D0, we're going to start from ij, so this becomes 0, 0. Okay, we have D0 again, D0 again, I is 0, and k is now 1. Okay, now k in this case is 1, so it's going to be there, j 0. Okay, D0 0, 0 is 0, 0, 1 is negative 2, and 1, 0 is infinity. Okay, so we combine these, then we take the minimum, and the minimum is just 0. So this just remains the same. Now we're going to go over to j plus 1, which is 1. So let's edit these values. And as I was saying, this value is just going to remain the same per row. So we can just leave this as negative 2. We just replace the j value. So here, 1, 1. Okay, the value at 0, 1 from D0 is negative 2. And the value at 1, 1 is 0. Okay, combine these, then get the minimum, which just stays as negative 2. Okay, now we move on to j plus 1, which is 2. All right, again, let's replace the j values. So this becomes 2, and this becomes 2 as well. Okay, so 0, 2, this is infinity, and 1, 2 is 2. Okay, we're going to combine these. This gets 0, then we get the minimum from these two, which is 0. So the new value here is 0. And we repeat the process until we reach this last box here. And then once we reach this last box, we know the entire graph is fully complete. And this D1 can keep on going to D2, keep on going to D3, D4. It can have multiple iterations. And the most important part is just to keep in mind what K is. So in this case, K is 2, this case, K is 3, this case, K is 4. And yeah, all you have to do is just plug in the values here. So K minus 1 when we have D2, which is B1. And the whole idea is that you're just referring to the previous list and grabbing values from it. You're referring to the previous list, grabbing values from it, and you're referring to the previous list and grabbing values from it. And then from there, you just fill out the chart, or you fill out the graph one by one. Yeah, and as I was saying, just once you reach this last box, then you stop. Yeah, that's about it. It's pretty simple. Yeah, just keep in mind that all of these empty boxes are infinity because it may not be reachable from this node here. But yeah, once the graph is fully filled out, you'll see which nodes actually aren't reachable. And then you'll see the minimum or the shortest distance from node I to node J. Yep, that's all.